Okay, students, in the first video, we discussed about the systems of units and what are the characteristics of a standard unit. And when we are discussing about the systems of unit, we have discussed four systems of unit: CGS, NPS, FPS, and SI. As in the last video, I told that the SI is the advanced system of unit, and in that SI system we use 7 basic fundamental physical quantity and their units, and in addition to that two supplementary units. So the 7 basic physical quantities already you know that, clear, and the two supplementary units, that the plane angle and solid angle. And I promised that in the last video we will discuss that later. In this video I will give you a little bit of idea about the two supplementary units, and already you know about the 7 basic fundamental physical quantities and their units, that we will discuss in the later stage. That already you know some of the physical quantities, and there are some are there which we will discuss in the later course of time. And in this we have used the two supplementary units in SI. The two supplementary units in SI are plane angle, and second one is the solid angle. What is this plane angle and solid angle? Now let me discuss about this. What is this plane angle? The plane angle, we can say that. What is this plane angle? That is the radian. Assume it is a radian. So what is that radian? And what is the solid angle? Straight line. Straight line and radian. So what is this radian? So in short form we will write it as a RAD. So what is this radian? It is the plane angle between. What is this radian? It is the plane angle between. It is the plane angle between the two radii of a circle. Which cut off on the circumference of what? Circumference of the circle. And R of length equal to the radius of the circle. Here it is the plane angle between the two radii of a circle which cut off on the circumference of that circle, and R of length equal to the radius of the circle. So we can write the formula like that: theta is equal to an arc of length L divided by radius. That is the radius. Means 1 radian equal to, when this L equal to R, then theta is equal to, theta will be 1 radian. If I show that, let us consider a circle and the center. What is the plane angle? It is the plane angle. What is the radian? It is the plane angle. On this plane, I have drawn the circle. Between the two radii of a circle, consider two radii. 1 and 2. There are two radii. R and R. Which part of on the circumference and R. This is the R part on the circumference. What is the length? L. Length equal to the radius. If L is equal to R, then this will be 1 radian. This is equal to 1 radian. Or if this is theta, then theta is equal to this R by radius. This is called the plane angle and the unit is a radian. Okay. Then next we will go for the solid angle. So the solid angle, it is a 3 dimensional. It is a 2 dimensional. It is of the plane. So think about a sphere. When I discuss about the solid angle, think about a sphere. So let me write. It is the solid angle subtended at the center. It is the solid angle subtended at the center. The solid angle subtended at the center of a sphere. Solid angle means a 3-dimensional angle. Subtended at the center of a sphere. By an arc by an area, not the arc, by an area of its surface equal to the square of radius, equal to the square of radius of the sphere. Radius of the sphere. So that is called the stadium. Clear? So this stadium, if you understand this stadium, SR, short form we are writing SR. So what is the stadium? Consider a sphere, and if you consider a sphere, and let us consider the sphere is like this. The 3-dimensional. For a sphere, it should be a 3-dimensional. It is the solid angle subtended at the center of the sphere by an area. Means if it is a sphere, it will call an area like this. Let me draw the area like this. This is an area on the surface of the sphere. Center of the sphere by an area of its surface. So area of its surface is the surface of the sphere. The sphere is a 3-dimensional. So this is an area on the surface of the sphere equal to the square of radius. So this can be called like this. This is the radius and radius. Then if this area is ds and r the radius, then the solid angle, we can say the solid angle or this b omega, small solid angle you can say, or omega. Suppose this is an area, suppose I will take as s and r, then the solid angle, once radian, omega, it is represented as omega. This is equal to 1 omega equal to this area divided by the radius square, s by r square. So it is the form like that. You are from a sphere, you are taking a conical shape. You are taking a cone shape. Take a sphere and cut the sphere so that you will get a cone from that sphere. With the apex of the cone, the apex of the cone is at the center of the sphere. This is like that. So this area is called on the surface divided by r square. That is called as the stadium. Clear? So this is about the plane angle and the solid angle. And for the small case, I have written like this. If this is d omega, for small we are taking d omega, then this area should be ds. Because r is the fixed, so ds small area is ds and small angle is d omega solid angle, that is the small solid angle straight radian. So that is the definition of radian and straight radian. Clear? After that, now we shift to, now we go for the SI system. We are using this SI system, and I have already told that the SI system is a internationally adopted system, and you can say nowadays we are using the SI system of unit, because what are the advantages of using this SI system of unit? Now we discuss about the advantages of using the SI system of unit. So next we will go for the what are the advantages of using this international system of unit. So next is the advantages of SI system of units. What are the advantages of SI system of units? What are the advantages of this SI system of units? First, this system, it is a rational system of units. First advantage is it is a rational system of unit. It is a rational system of unit. So what is the meaning of this rational system of units? What is the meaning of this rational system of units? So what is this rational system of unit means? We are using one unit for different form of the same physical quantity. Let me give an example that in the rational system of unit means one physical quantity we should give one unit. So what that means? One physical quantity there should be one. As you know, energy is a physical quantity and it is a derived physical quantity. So when you discuss about the energy has different forms. Then I will ask you, how much energy, with what energy I can push the table so that it will go to a distance of 5 centimeters. If I say that and if I ask you, then you measure and do the calculations and you will tell that I should use some value of energy with a unit, because in measurement we have discussed the energy means when I discuss about the mechanical energy, the meaning is that when I discussing about the mechanical energy, that when I push the mechanical energy, that unit is we are using joule or ohm. So that is we are using for mechanical energy is joule. So if I ask you heat energy, what is the heat energy? Heat energy is measured in calorie. Heat energy is measured in calorie. 5 calorie of heat is supplied to a body. Means 5 calorie. 5 is the numerical part, calorie is the unit part. So heat energy is measured in calorie. Then electrical energy. Electrical energy that we are measured in watt hour, watt second, like that. So the electrical energy measured is watt hour or watt second. So here mechanical, heat, electrical, these are what? The form of energy. But energy is a one physical quantity. In physics we will say energy is a one physical quantity. For it has different forms. For different forms, we will not use different types of units. SI system makes what? We will use one unit for energy, that is joule. So that's why it is called as a rational system of unit. It is a rational system of units. So all of you got that? What is the rational system? Means SI make use of one unit for one physical quantity. Means the physical quantity is energy. May be of different form, but one unit for one physical quantity. This is the rational system of unit. Okay? Clear? Now next we will go for the number 2. Here, what is the rational system of unit? Then the next number 2 advantage is that the second advantage, SI is a coherent system of unit. That the SI is a coherent system of unit. Number 2, it is a coherent system of unit. 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 What it means? All the derived units means the units of derived physical quantity, because the derived physical quantity are derived from the fundamental physical quantities. So all the derived physical quantity units of the all derived physical quantities or the units derived units can be obtained by dividing and multiplying the basic and supplementary units. The basic and supplementary units. And no numerical factor are introduced. No numerical factor are introduced. So means, what is that means is the coherent system of unit means, you can say that in this system all the derived units can be easily obtained, by what? Multiplying and dividing. By multiplying or dividing. By multiplying or dividing the basic and supplementary, because here there are basic and supplementary physical units. All the derived units can be easily obtained by multiplying or dividing the basic or supplementary physical units. Means what? It is a coherent system. Means suppose I want to find the unit of area. What is the unit of area? Area is a derived quantity. And the unit of area is a derived unit. It is a derived physical quantity and the unit is a derived. So, because already you know that the 7 basic and 2 supplementary units in SI, already you know that. So, area is not there in that 7 plus 2. So, area is a derived physical quantity and its unit is a derived unit. And it can be easily obtained by multiplying or dividing. Means, when you calculate this area should be equal to, already you know the formula is length into breadth. It is always length into breadth or length square, right? That is the area. So area means that is the multiplication of two lengths. So length and breadth. Length is measured in meter and this breadth is also measured in meter. So I can write this as meter square. So the unit of area is obtained by the two basic physical quantity in SI, that is length and length. Breadth is also a length. And by multiplying, I am getting the, without using any numerical value. I am not using any numerical value. I am not multiplying 2, 5, 7 like that. I am getting the unit of, right? Similarly, if I will go for a unit like here, suppose I will go for a unit like here, your speed. Suppose I find the unit of speed. So as you know, speed is the derived unit and it depends on a distance which is a length divided by time. So this is simply division. What is the unit of distance? That is meter. What is the unit of time? Second. So that is the unit of speed, meter per second. So this is a meter per second, or you can write meter second inverse, right? Meter second inverse. So this unit of speed is derived by division, simply division. I am not using any numerical value. I am not multiplying 2 or 5 or 7 like that in this part. So without introducing any numerical value. Clear? So this is, that's why it is called as a overhead system of units. Clear? Next, the third advantage is that it is a metric system of unit. It is a metric system. It is a metric system of unit. What does this mean? It is a metric system of unit. Means what? It is a metric system of unit. Means what? Multiples and submultiples of SI. The multiples and submultiples of SI can be expressed as the power of 10. Multiples and submultiples can be expressed as the power of 10. So what this means? A metric system means the multiple and submultiple can be expressed as the power of 10. What the multiple and submultiple? Suppose I will ask you 1 kilogram, 1 kg. Okay, so 1 kg, I can write this as 10 to the power 3. Metric means 10 to the power 3. That is a multiple of gram. So it can be expressed. It is a metric system. Means to get this 1 kg, you can write this as 10 to the power 3 gram. That is a multiple. Suppose I will ask you 1 millimeter. 1 millimeter. So what is that milli means? What millimeter? If I write this is equal to 10 to the power minus 3 meter. So it is a submultiple. 10 to the power minus 3. Negative means submultiple. And the powers of the important thing is metric system means to express that 1 kg, I can use this 10 with the multiple or submultiple. Minus 3, 2, 5, 9, whatever. We can express that in this way. So it is a metric system of unit. Okay? Then we will go for that. Next is that it is a comprehensive system. It is a comprehensive system. It is a comprehensive. It is a comprehensive system. So it is a comprehensive system. Comprehensive system. What is this comprehensive? It is a comprehensive system. Means what? What does this mean? Comprehensive. Comprehensive means it covers all branches of science and engineering. It covers all branches of science and engineering. Means to get the unit of any physical quantity till today, we can use the SI system. To get the unit of any physical quantity till today, we can use this SI system. So it covers what the units are coming in science and engineering, physical quantities and their units. We can find that from your SI. So that's why it is called as a comprehensive system of clear. Then this is the comprehensive system of unit. Okay. So first one is the rational system. Next is the overhead system. Then it is the metric system. Then we will get the It is a comprehensive system, and the most of important is it is internationally accepted. And is also advantages. It is internationally accepted. Everywhere it is accepted. If you go to America, England, or France, or any country, we can use the SI system of unit. But when we are discussing about the FKS system, that is also called the British system of unit. Nowadays we are not using foot, pound. All these are not used. So we cannot say this is an internationally adopted system. But kg in SI, to measure the mass, we are using kg, and to measure the length, we are using meter, right? And to measure the time, you are using second. To measure the current, you are using ampere. These are the units. These units are internationally, means to measure current in India, we are using ampere. To measure current in Australia, we are using ampere. So that is a internationally adopted system. So these are the advantages of our SI system of units. Now when I am discussing about the metric system of units, there I have used the relation 1 kg I have written there is equal to 10 to the power 3 gram. 1 kg equal to I have written that 10 to the power 3. 1 kg I have used that 10 to the power 3 gram. So for this kg I am using a multiple of 10. And that multiple of 10 to the power 3 can be replaced by a word called as kilo. Before meter, I am using a word kilo. For that kilo, I am making that is equal to 10 to the 3. Means I am using a prefix for a multiple of 10. Similarly, I am using a milli prefix for the multiple, submultiple of 10 to the power minus 3. Then I am using the relation. Then I will use the example is there. And that's it. Here we will discuss about there are some terms or prefix we are using for the multiples and submultiples of 10. So we can write this as abbreviations in power of 10. We can write this as abbreviations in powers of 10. We are using the abbreviations in powers of 10. Okay, abbreviations in power of 10. What are the abbreviations we are using in powers of 10? Here I will make this as two parts. One is the submultiples and the multiples. Submultiples means negative powers of 10 and submultiples are the negative powers of 10 and multiples are the positive powers of 10. So next I will use the submultiples. First I will use the submultiples. So we will remember this means submultiples. For the submultiples, I am using a prefix like that. I will write like this prefix, and for that prefix, I am using a symbol. What is the symbol for that prefix? We are using a symbol. Then for that we are using the power of 10 or multiply of 10, multiplier of or multiply factor or multiply, simply we will write multiply factor, or you can say this is the powers of 10. What I am using. So you will remember like this: deci, centi, milli, micro, nano, pico, femto, atto. Here deci, centi, milli, micro, nano, pico, femto, atto, zepto, right? So like other can use also. There is also called as Yapto. So what I said, these are the prefix. Means they should be written before the fundamental unit, right? Like your mass, length, type. Before that we use this prefix. For this we are using the symbols are like that. Deci, small letters D. Centi, C, small m. Micro, mu. This is mu. Micro, nano, small p, pico, femto, atto, small a. And that here, jepto, small j, jepto, y. We are using the symbol for that. I will show you how to write that. Then, now what are the powers we are using that is, deci means we use that replaced by 10 to the power minus 1. Centi means 10 to the power minus 2. Milli means 10 to the power minus 3. How to remember this? How I remember, I recall that I am writing in that form. First I remember this sequence, then I am using this one. Minus 1, minus 2, minus 3. Micro means 10 to the power minus 6. I will shift to minus 6. There is no minus 4, minus 5. Then nano means 10 to the power minus 9. Then pico means 10 to the minus 12. I am using 3. Then femto means 10 to the power minus 15. Atto means 10 to the power minus 18. Then jepto means 10 to the power minus 21. And jepto means 10 to the power minus 24. Clear? 10 to the power minus 24. So this is the multiplied factor. Means what? When I am using this, how I will use this one? The sum multiples. The important thing is remember this word prefix, then how it is. Suppose I use a nanosecond. One will write as 1 nanosecond. So nano is a prefix. Yes, for your now this question, nano is a prefix. For this nano, what I am using some multiply factors 10 to the power minus 1 powers of 10. So I can write in place of nano, I will put this 1 as 1. For nano, I will use a numerical value, that is the powers of 10. What is that? 10 to the power minus 9. And h in second is a second. So that means 1 nanosecond equal to, I can say this is 10 to the power minus 9 second. Suppose I will ask 2 nanosecond means I will make this as 2. 2 into 10 to the 9 second. Means for this prefix, I am using this one. Suppose I get a value like this. So you can ask, there is the gap 1, minus 1, minus 2, minus 3, but it is minus 6. Suppose I get a value is minus 10 to the minus 4. For that, how will I use this one? So this can be written as, this I can write as 10 to the power minus 1 into 10 to the power minus 3. Same thing. So for 10 to the minus 3, I have a prefix as milli. So I can say this is 10 to the power minus 1 milli. Clear? So if it is, suppose this is a 2 into 10 to the minus 4 meter. This is 2 into 10 to the minus 4 meter. How will I express that in terms of prefix? So 2 into 10 to the minus 4 meter means I write this as 10 to the minus 1. So 2 is 2. But 10 to the minus 4 is not there. So I can reduce that into like this, or I can go for 6. If I write this as 10 to the minus 6, then I will put this 10 to the power plus 2. So 2 into 10 to the minus 1 into 10 to the minus 3. So this 2 will do as it is. 2 into 10 to the minus 1 millimeter. Millimeter. So in symbol form I can write m for milli. For milli, symbol is m, meter m, mm. Right? Or this we can write 2 by 10, 0.2 millimeter. So this is, now the important point is that when I am using this prefix, it is very easy to make the numerical value or to remember the numerical value for a convenient, in a convenient way. That is the use of this soft multiples and multiples. Now we go for the multiples. So now we go for these multiples. Let me write the multiples again, the same logic I will do this one. What way I have remember this? I am using the same concept here so that you can remember this same abbreviations in powers of 10. These are the multiples or the prefix for these multiples. So the prefix are like this. How do you remember this? First I will take deca, hecto, kilo, mega, giga, tera, peta, exa. These are the prefix. Deca, hecto, kilo, mega, giga, tera, peta, exa. Then zeta. Right? Then for this zepto, we are here. For multiple case, it is a zeta. Similarly, yocto in some multiple, here we will use as a yoto. Double TA, yota. Symbol. So here, remember one thing. Here generally we are using the capital letters, but sometimes also we are using these small letters also. For deca, we can use this as a D, or you can say as a D also. For hecto, X, and for kilo, it is capital K. For hecto, you can say this is a capital X, kilo, or mega, capital X. It is no problem. You can use capital letters also. Mega, giga, G, tera, T, eta, P, capital, exa, E, Z, capital Z, zeta, capital Y is a iota. Clear? So these are the symbols. Clear? Next, the multiplier factor is what? Here it is the, for deca, use the same thing. 10 to the power, it is plus because it multiples 1. For hecto, 10 to the power 2. For kilo, 10 to the power 3. For mega, 10 to the power 6. For giga, 10 to the power 9. I am increasing 3. 1, 2, 3, then increase 3. Tera, 12. Peta, 15. Exa, 18. Zeta, 21. Iota, 10 to the power 24. So these are the multipliers. So the use, now we got the use of these things, right? Suppose I will ask you, or if I will say you, what is a, in this part, 1 peta-second. What is that 1 peta-second? For peta, what is the value? For peta, 10 to the 1, hecto 10 to the 2, kilo 10 to the 3, mega 10 to the 6, giga 10 to the 9, tera 10 to the 12, peta 10 to the 15, exa 10 to the 18, zeta 10 to the 21, iota 10 to the 24. For peta, I will use this as 10 to the power 15, and 1 is 1 into the 15, that is the 15 second. Clear? So that is the use of this. Clear? So in that case also we can convert from one value to another value by using these rules. But so this is the use of this. So suppose we have a value like 10 to the power 13 meter. So I can write this as 10 into 10 to the power 12 meter. So this is equal to 10. What is the 10 to the 12? That is your tera. So in place of 10 to the 12, I will use the prefix as tera, capital T, and meter. So 10 to the power 13 meter, I can use this as 10 terameter. Now students, you see here, when you are telling someone that length is 10 to the power 13 meter, but I will tell that the length is 10 terameter. It is the human tendency that then the numerical value is smaller, it is very easy or convenient to us to recall or to remember. So in this expression, it is very convenient to listen 10 terameter. So we are using the concept of this multiplier and submultipliers. Clear? So this is about the prefix and use for multiples and submultiples of But now after that we got the systems of unit, then what are the abbreviations, what are the advantages. Next we go to some important practical units, some important practical units. In addition to that, so see, in a pen and paper in our book, it is very easy to say that we are using these 4 systems of unit. Out of these 4, SI is the more advanced system. We will use the SI system for any measurement, all these things. But remember one thing, in your SI system, in our SI system of unit, we have the drawback, we can say that in our SI system, suppose in SI system the length is measured in meter. Clear? Suppose I measure the length in meter, and if I measure the distance from one hall to another hall in our college or in our periphery, then I can express that in meter. But when I measure the distance from R to Sun, then in that case I will not use that meter. I will use a practical unit, light unit, astronomical unit, that I will use. Means meter is there, but it is not convenient. If I use the meter, the numerical value will be large. So our tendency is that it is very difficult to us to remember a large numerical value. Better to make the numerical value smaller so that we can remember or we can recall that. So according to that, there are some units I will discuss here. One is the some important practical units. For the measurement of this length, we are using a unit that is called as it is the astronomical unit. Astronomical unit. That is symbol written as AU. It is the measurement for length. Clear? For length, first I will discuss for measurement of length. So if you are using SI, I will always take this thing SI. The unit is a meter, not like that. Practically, there are some, for our convenience, we are using the physics is for make the things simpler. So for our convenience, for measurement, I will not always keep that. I will keep that, or I will discuss that only. I will measure the length by using the SI system, and I will express that always in meter. No, that is not possible always. So I will use some practical units. In day-to-day life, we are discussing something, then we are using the practical units. So what is the astronomical unit? So what is this astronomical unit? It is the mean distance of the sun from the earth. It is the mean distance. It is the mean distance from the sun to earth. Mean distance from sun to earth. Why this mean distance? Means what you see. So suppose this is our solar system. In a solar system, here the sun is located, and this is our earth. I am not completing the total set. This is the sun, this is the earth. Suppose I measure a distance. Suppose someone will measure the height to this. This is also possible. Suppose I measure the height. Is the same distance is here? No. Suppose I will measure from height. Is the same distance is here? No. Suppose someone will measure like this. This is not the same distance. Sun and earth, because these are very large objects, very large size. So for that, we are taking the mean distance. We are taking the mean distance. And how about this is? The value is, let me write the value is 1 astronomical unit, 1 astronomical unit. That is equal to 1 astronomical unit is equal to 1.496 into 10 to the power 11 meter. 10 to the power 11 meter. Or generally this is written as 1.49 or 1.5 into 10 to the power 11 meter. So this is the 1 astronomical unit. Clear? So this is the one astronomical unit. So if this means by using, if there is a 3 into 10 to the power 11 meter, means I can say that if it is 3, then nearly you can say that there is 2 astronomical units. So by remembering that 3 into 10 to the power 11 meter, I can say that is 2 astronomical units. That is convenient. So this is used to measure the distances in our planet to planet, Earth to Sun, like that. Clear? Then the next another unit used for measurement of length, practical unit. We are discussing for length. All these are for length. The fundamental physical quantity is the length. It's unit, the practical units of length. The next one is the light year. What is this light? It is the distance traveled by light in vacuum in 1 year. It is the distance traveled by light in vacuum in 1 year. It is the distance traveled by light in vacuum in 1 year. How much this is? You can know that 1 light year is equal to. So as you know, what is the distance traveled by light in 1 second? The speed of light in vacuum, 3 into 10 to the right? So 3 into 10 to the power 8, as you know that, it is the distance in meter. 3 into 10 to the power 8 meter in 1 second. So in 1 year means 3 into 10 to the power 8 meter into, this is the distance, into 1 year. So this is the meter per second. This is in 1 second. This is the distance in 1 year into 1 year. Clear? 3 into 10 to the power 8 meter per second into 1 year. And if you convert this year into second, how will I write this as? 3 into 10 to the power 8 into, year means what? 365 days. Clear? 1 day has a 24 hours. 1 day is I make this as a days. Then this is 1 day, 24 hours. That hour is converted into this hour to minute. 60, in 1 hour there are 60 minutes. In 1 minute there are 60 seconds. So I make this a second. 1 year is this much of second. So you can multiply this second. So this is the total distance. So means I will write this as this much of meter. So if you multiply that, you will get that is equal to 9.46 into 10 to the power 9.46 into 10 to the power 15 meter. This is equal to 9.46 into 10 to the power 15 meter. Clear? Or you can write this as nearly equal to 9.5 into 10 to the power 15 meter. Clear? So that is the one light year. So this light year is used to measure the distances in our astronomy. Means from one planet to another planet, right? Or nearby stars, but from our sun, the nearest star, what is the distance? That can be measured by the light year. Okay, so as you see here, the light year is of the order of 10 to the 15, astronomical unit is of the order of 10 to the 11. So which one is greater? Light year. This distance is larger than the astronomical unit. And the most important one, so I can write this as 1 light year is equal, I can write 9.46 into 10 to the power 15 meters. So 1 light year is equal to 1.96 into 10 to the power 15 meter, or that is equal to 9.46 into 10 to the 15 meter, or I can write it as 9.5 into 10 to the power 15 meter. That is the light year. Then the other unit for measurement of length is the parsec. Very, very important one. What is this parsec? Parallactic second. Parsec is the para paralactic second. Percent is the paralactic LLACTIC second. Remember, generally there is a confusion between the student that it is written as second. So it is not the unit of time. It is the unit of length. Practical unit of length. Don't get confused. If there is a second, means it is for time. No, it is for used to measure the length, and it is a practical. It is a practical unit. And this is also used in measuring distances. Used in astronomy. In astronomy, to measure the distances, we are using this percent. So what is this one? It is the distance at which an arc of length. It is the distance. Let me write the statement. It is the distance. It is the distance at which an arc of length, one astronomical unit. Arc of length, one astronomical unit, right? One astronomical unit subtends an angle. Subtends an angle of how much? 1 second. 1 second. That's why there is a term called as a second. Subtend an angle of 1 second. In our words, the second hand. In 1 second, how much angle is subtend? That is the called as that angle is measured in a second. So angle in a 1 second. Clear? Next, in a 1 second of arc. Clear? It is the distance at which an arc of length 1 astronomical unit subtends an angle of 1 second of arc. 1 second of arc. Or you can say it is maybe also be defined as the radius of a circle. It is also defined as it is the radius of a circle. It is the radius of a circle. Go for your plane angle. It is the radius of, remember that plane angle. It is the radius of a circle. It is the radius of a circle at the center. It is also defined as it is also the distance. It is also defined as the radius of a circle at the center. At the center of which an arc of length and arc of the circle. So what have written? What have written? It is the radius of a circle at the center of which an arc of the circle one astronomical unit long subtends an angle of 1 degree. Subtends an angle of 1 degree. Oh, sorry, 1 second. Not degree, is the second. Or 1 second. Okay. So 1 second can be written as 1 double dash. 1 second. That can be written like this. So what is understand this? It is the distance at which an arc of length 1 astronomical unit subtends an angle of 1 second of arc. 1 second of arc. Okay. So suppose I will say that. So astronomical unit is the mean distance from the sun to earth. Let us consider there is your sun and there is your earth. Clear? So this is the arc from sun to earth. Clear? What is the distance? 1 astronomical unit. Clear? 1 astronomical unit. And this one astronomical subtends an angle of how much? Suppose this is the center. How much? 1 second. 1 second like this. Subtends an angle of how much? 1 second. Then this distance, here, this distance is called as 1 or sec. Here, this distance is called as 1 or sec. Okay? Clear? So 1 astronomical unit, subtends an angle of 1 second. Then the distance. It is the distance at which? Distance at which an arc of 1 astronomical unit subtend an angle of 1 second of arc. 1 second of arc. Okay? And this 1 parsec equal to, let me write the value. 1 parsec is equal to, if you calculate that second, you can make that second into angle, so you will calculate, and 1 parsec equal to, the value is 3.08 into 10 to the power 16 meter. 3.08 into 10 to the power 16 meter. Now compare this thing. These are for astronomical purpose we are using. Which one is larger? Parsec is larger than light year. Which is larger than astronomical unit? Clear? And so I can write this to the length of both, but I am using light year, parsec, astronomical unit, but which one is larger among all? That the parsec larger than light year, and light year is larger than astronomical unit. So I can say parsec greater than light year greater than astronomical unit. Clear? And remember the relation is that, and already you know that values. So 1 light year, then the relation will be 1 light year. 1 light year, I can write this as 1 light year equal to 6.3 into 10 to the power, this is for understanding, 4 astronomical unit. That is a conversion. 1 light year equal to this much astronomical unit. And 1 parsec is equal to, you know the value, so divide that, you can get 3.26 light year. So parsec equal to 3.26 light year, 1 light year equal to this much of astronomical unit. Okay, so these are the different units used for length, and these are for these length measurements. So what we discussed, these are used for very large distances, right? We are using the distances for macroscopic level. Astronomy we are using for long distances, but similarly when you are measuring for the small distances, you are measuring the radius of the nucleus and the radius of an atom. For that, we are not using these light years or astronomical unit or parsec. Then we are using small distances like. So one of the small distances to measure that length is the Fermi. This is for micro. You can say micro distances. We are measuring the micro distances, small distances. Fermi. So it is the smallest particle unit of distance. It is the smallest particle unit of distance. Okay, and it is used to measure the nuclear size. It is used to measure the nuclear size. It is also called femtometer. The Fermi, the short form, it is also the femtometer. Now when I told this femtometer, then you can say what is 1 Fermi. 1 Fermi is the femtometer. So 1 Fermi is equal to 1 femto. Femto means what? 10 to the power minus 15 meter to meter. Femto means 10 to the minus 15 meter. So we are using the prefix. So femtometer short form we are telling that is a Fermi. So 10 to the minus 15 meter, and this is used for nuclear size. Similarly, nanometer, already know that nanometer. 1 nanometer equal to 10 to the power minus 9 meter. 10 to the minus 9, nano means 10 to the minus 9 wavelength of light. These are used for measurement of the wavelength of light. And this is used for measurement of wavelength of light, very small. So Fermi, size of nucleus. Size of nucleus. Clear? That is a nanometer. Then another one is I am using that micron. Micro. We are using this micro. This micro is nothing but there is a short form of micrometer. Then you will know that what is that micro. Okay? It is the micrometer. This is the micrometer. So 1 micro means micrometer. Micro means what? 10 to the minus 6 meter. 10 to the minus 6 meter. Clear? So these are the small measurements for this measurement of length, practical unit for microscopic or micro distances. Then in addition to that, there are some, by using this length, we are practically using some other units for measurement of areas. By using this length, we are finding the area. Area is a derived unit. But for this area also, if you are using the fundamental, the SI system of unit, if I ask you what is the area, you will always say the area will be in meter square, because it is meter and meter, because length and length. Length is unit of length is meter, so this should be meter square. But that is not always. Practically we are using some other units like for area. That is one is the called as the bar. For area measurement, practical units for area, one is the bar. For area measurement, it is the bar. Clear? So this bar, when you are using this bar means it is used to measure very small areas. Nuclear cross-sectional area, to measure the cross-sectional area of a nucleus, we are using this bar. So 1 bar equal to 10 to the power minus 28 meter square. 1 bar equal to 10 to the power minus 28 meter square. Meter square is for area, but 1 bar, in short form you can say 1 bar equal to 10 to the power minus 28 meter square. Then array. Then another one is array. 1 array. 10 to the power 2 meter square. In place of 10 to the power 2 meter square, we are using that array. Then another one very common to all of you using that area for measuring large areas. For measuring the large areas, we are using that value as acre. 1 acre. Acre. So 1 acre is equal to 4047 meter square. 4047 meter square. Clear? So 1 acre, we are using that is equal to 4047 meter square. And hectare. 1 hectare is equal to 10 to the 4 meter square. We are using hectare. For measuring the length, we are using this form, acre, hectare. So these are for small and these are for large. This one is for small measurement, cross-sectional area of nucleus. These are for large measurements. Bomb, air, acre, hectare. Clear? So these are for simply for measuring the area. Then let's go for some practical units for mass and very large mass. Not the small mass, for mass, but it is for macro, very large mass, macro, large, micro, small. So very large. So for mass, the following are the large mass is the one is the Chandrasekhar unit. Chandrasekhar limit. Li Chandrasekhar limit. CSL, short CSL, Chandrasekhar limit. What is that Chandrasekhar limit? The Chandrasekhar limit is the 1 CSL, 1 Chandrasekhar limit is equal to 1.4 times the mass of sun. So already you know that the sun is a very massive body. The sun is a very massive body, and that 1.4 times the mass of sun. And the mass of sun is already you know that the mass of sun is that is equal to 1.4. And when the mass of sun is around 1.9 into 10 to the power 30. 1.9 into 10 to the power 30. So 1 CSL is this mass. So very large mass. For Chandrasekhar, we are measuring for large mass. We are using the Chandrasekhar limit because this is comparing with the sun. Sun is a very heavy massive body. Clear? Then others are like here ton or metric ton. 1 ton or what is it? 1 metric ton. Ton or simply ton or metric ton. Ton or metric ton. So this is equal to how much? 1000 kg. Clear? Quintal. We are using 1 quintal. The practical unit for mass 1 quintal is 100 kg. 1 quintal is the 100 kg. And remember one slab. 1 slab or mass 14 point. So this is 14.5 or you can say that 14.57 kg. 14.57 kg or 59. 14.57 or 59 kg. Okay. That plus 0.1 difference is allowed. So we can say up to 14.57. Some places you will find that is 14.59. Right? So 14.57 kg. Then pound. 1 pound. This is in short form LB. Nowadays, if you see that some measurements, then we are finding LB. They are somewhere some people are also using this pound also in some country, like in Britain. They are using LB means pound. 1 pound. So 1 pound equal to 0.4536. 0.4536 kg. Pound. Clear? So this is the pound. Is the units for measuring the large masses. For measuring the small masses, we are using some other units like one. We are using frequently in our chemistry. When discussing chemistry, you are using frequently this unit, that is the atomic mass unit. For measuring the mass, we are using atomic mass unit. In chemistry, are acquainted with this word AMU for measuring mass. Atomic mass unit means this is used to measure small masses. What is that atomic mass unit? It is the mass. It is used to measure the mass of atoms, nucleus, like that, and expressed in AMU. It is defined as, what is that AMU? It is defined as 1/12 of the mass of carbon. Of the mass of carbon. Which mass of carbon? Atom. Which isotope of carbon? Carbon is different isotopes. So one of that is the C, mass number 12, atomic number 6. Mass number 12, carbon of one isotope, that is a mass number 12, atomic number 6. So the mass of one carbon atom of this isotope. Not the carbon is 13 mass number is also there. So we are not using that carbon. We are using the carbon, one of the isotope of carbon whose mass number is 12, atomic number is 6. Take that one atom. From that one atom, take how much? 1/12 of the mass of that atom. That will be one atomic mass. So 1 mu, then we can write 1 mu. In short also, you can also write 1 u. Simply we can write 1 u, that is equal to 1.66 into 10 to the power 1.66 into 10 to the power minus 27 kg. 1.66 that is the minus 27 kg. It is very small. That is the minus 27 kg. So another one is 1 carat. Carat. For measuring the gold. Carat. 1 carat equal to, or we can write 1 C. That carat is equal to how much 1 carat? 200 milligram. Very small. Means 200 milligram. Okay. Then now we go further. This is for small masses measurement. We are using the practical units. Then others like your practical units we are using for time. For some practical units for measurement of time are like for measuring the time. So for practical units like one is the one we can say the solar day. What the solar day? It is the time interval between the two successive passes of the sun across the meridian. That is a solar day. Means it is the time taken by the earth to complete one rotation about its own axis with respect to the sun. It is the time taken solar day. What is the solar day? What is the solar day? It is the time taken by the earth to complete one rotation about its own axis. Already know that solar day. The time taken by earth to complete one rotation about its own axis. That means it is around what? One solar day is around 24 hours. A day is 24 hours. The sun, earth takes 24 hours to complete one revolution around its own axis. Then another one is the sidereal day. Sidereal day. Sidereal. What is this sidereal day? A sidereal day is what? It is the time interval between two successive passes of a fixed star or any fixed star. Sun is not a single star. There are so many stars are there on our solar, in our galaxy. So it is the time interval between two successive passes of a fixed star across the meridian. Across the meridian. Or you can say it is the time taken by the earth to complete one rotation about its own axis with respect to a distant star. It is with respect to sun. It is for any other star. That for that it is called as a sidereal day. Or this is around the sun with respect to sun of its own axis, own axis with respect to sun. Clear? It is solar day. Sidereal day around its own axis of its own axis with respect to other star. Sun is a star like that. There are other stars. So with respect to other star. Okay. Then solar year. What is the solar year? The solar year is the one solar year. To complete one revolution around the sun by the earth. Right? Already you know that solar year. But that solar is the time taken by the earth to complete one revolution around the sun. Around the sun. One solar year equal to around 365 days. Not exactly that one. You can say, what is the exact value? One solar day. One solar year equal to how much? You can say that one solar year equal to 366.25 average solar days. Right? 365.25. Then again then comes your leap years from that. We are not taking that 0.25 part. That 0.25 add up, and we are getting that 1 day extra after 4 years. Clear? So that's why in the month of February we are getting 29 days, right? 1 extra day. So around 1 solar equal to 365 days. Okay. Then one is the tropical year. What is the tropical year? The year in which there is total solar eclipse. Solar eclipse is called tropical year. Tropical year. What is the tropical year? Tropical year the in which there is a total solar eclipse. There is a total solar eclipse. Solar eclipse. Surya Parag. Solar eclipse. Okay. Then another one is the leap year. What is leap year? We are using that leap year is the year which is divided by 4 and in which the month of February has 29 days. The month of February has 29 days. I told you like that. So that is the leap year. Okay. Then it's called a leap year. The year which is divided by 4 and in which February has 29 days. It comes in after 4 years. February has 29 days, but usually it has 28 days. After 4 years, every 4 year interval, we are getting the February month of February has 29 days. That is called as a leap year. Then lunar month is lunar the word is what? For moon. Lunar is for the word is for moon. We are using this lunar. For sun, solar. For moon, lunar. So what is this? It is the time taken by the moon to complete one revolution around the earth. Moon around the earth. Earth around the sun, solar day. Moon around the earth, lunar. Okay, it is the solar year. Earth around the sun, solar year. Moon around the earth, that is the lunar month. What is that lunar month? One lunar month equal to 27.3 days. Means within this 27.3 days, the moon revolves around the complete one revolution around the earth. Okay. Then there is other unit is the very small unit. We are using that for time. That is your parsec. That is for time. These are for measuring large time intervals or large time. We are measuring or we are using these practical units. Then one is the 1 sec. Small unit of time sec. What is that 1 sec? We are telling that secking. 1 sec. So 1 sec is the smallest practical unit of time. 1 sec equal to 10 to the power minus 8 second. 10 to the power minus 8 second. That is a sec. Okay. Similarly, another one you remember that for pressure. So these are the fundamental units of derived length, mass, time. I have discussed another derived units for area. Generally, we are using in our day-to-day life. Then another one is the for pressure. Generally, we are using in day-to-day life for measuring the pressure. So for pressure, 1 bar. Pressure is measured in already know that it is a Pascal. But the other practical units are like 1 bar. Bar is used for measuring pressure. 1 bar is the 1 atmospheric pressure. 1 atmospheric pressure. 1 bar is the 1 atmospheric pressure. And if you measure that 1 bar, that is equal to 10 to the power 5 Pascal. 10 to the power 5 Pascal. Or simply it is a PA. What is that Pascal? Pascal pressure is a derived unit. Pressure is a derived physical quantity and its unit is a derived unit. So to get that pressure, Pascal is nothing but 10 to the 5 Newton or meter square. So 1 bar is equal to 10 to the 5 Newton per meter square or Pascal. Similarly, your 1 millibar, 1 millibar, 1 millibar. So what is that 1 millibar? That millibar, if you make that in pressure in calculation. So now you see here milli, deci, centi, milli, or milli I can write 10 to the power what? 1 into 10 to the power minus 3 bar. But 1 bar is equal to how much? 10 to the 5 Pascal. So I can write 10 to the minus 3 into 1 bar equal to 10 to the 5. It is into 1 bar. So 1 bar equal to 10 to the 5 Pascal. Pascal. So this is equal to what? 10 to the 2 Pascal. That is the calculation for millibar. So 1 millibar means what we will say? 10 to the 2 Pascal. Clear? Similarly, 1 torque. And what is that? 1 torque. The torque is used to measure the pressure. 1 torque equal to 1 millimeter of mercury. 1 millimeter of mercury. That is your ST. Symbol is your 1 millimeter of mercury column. 1 millimeter of mercury column. Okay. 1 millimeter of 1 mm of mercury column. Okay. So this is for torque. And 1 atmospheric pressure. You know what that is? Very important one. 1 atmospheric pressure. 1 atmospheric pressure is equal to, that is the measure for pressure. 1 atmospheric pressure, that is equal to 1 bar, which is equal to 760 mm of mercury. 760 mm of mercury column. Mercury column. Okay, or that is equal to 760. 1 millimeter of mercury column is how much? For 760 torque. So this is a relation for measuring the pressure. Similarly, others are like here. We are using the for power, for measuring the power. Power is also a derived physical quantity, and so it is a for practical use we are using watt. So for power, watt. 1 watt is equal to joule per second. 1 watt equal to joule per second. So power is a practical unit called as a watt. So other is the horsepower. We are using the motors. They are telling that horsepower. This motor has this much of horsepower. Means that is a HP. 1 HP horsepower is equal to 746 watt. So these are the practical units we are using our day-to-day life. Okay. So well students, this is the all about the fundamental or the introduction to know about the unit, how the units are measured. And by using this concept, now we can go for measuring and expressing the physical quantities. But when we are using the SI system of unit, as I told that SI system of unit, we will not keep in mind that we will always, or it is not mandatory that I will always use the SI system of unit to express any measurement. I can use the practical units to express this measurement of or the measurement of different physical quantities. Clear? So go through this video, and in addition to that we will also come across different practical units in our day-to-day life that we will discuss in the later due course of time. Okay. So, well students, this is about the advantages of SI and abbreviations used for multiples and submultiples, and also for the some of the practical units. Okay. Thank you students.